Hi guys, Assalamualaikum. Today, not today, for this video, part 5 of shear wall design. What we have done so far is we have provided the main reinforcement for your shear wall for from the ground to the first floor. Okay. Now we want to check at the rooftop whether we can use we can extend the same reinforcement or not up to the roof. So we are going to repeat almost the same procedure as previous step. Okay, start from where? Start from here actually. Okay. We need to figure out what is the moment here. Okay, we have done what we have done so far is we have designed here. Okay, we have calculated this one 18.39 if I'm not mistaken, the value of the moment here, and this one is around 9 point something the moment, and we have calculated we have designed the main reinforcement. Okay, and now we want to check whether the same reinforcement we can extend to the fifth floor here. We don't have this one here. I override the height. Okay, just until level 4, and here is level, not level 5, roof. Okay, roof. So for this area here, whether we can use the same reinforcement here at here. So we need to figure out what is the moment here and moment here. So in order for us to do that, we need to use this step, the same step here, to figure out firstly at the roof level. This one level 1, we get what is the value here and what is the value here, right? And then if we want to get the roof level here, so we have to get the roof level, we have to calculate the roof level. We will get one value here. Okay, but what is the value here? We need to analyze in level 4. Okay, so this step we will need to do it twice. Okay, but we don't have to calculate the stiffness because we are using the same size. Okay, for K here. K I over L, we have the same B, we have the same H, okay, and we have the same L, which is the slab, okay, the length of the slab here, L. So K for slab is the same 0.744. K for wall upper and wall lower, slightly different, where for level 1 we have 4.5, right? And from level 1 to level 2 we have 3.5. So up to until the roof floor here, it is 3.5. Okay, just from ground to level 1 here is 4.5 meters. So we will only use this one, 3.72 for the K. Okay, so we will use the same value, 3.72. What else we will use? What is the same thing? FEM, it is not the same thing. The value of W is also not similar, okay, because this is 5.63 and 4.8 is for floor loads. Okay, what I mean by that is it this one, yeah. Okay, at the very beginning of this videos of this example, for the floor 5.63, and you cannot see at the bottom here, there is a 4.8 value of GK. Okay, for the roof we are going to use this 5.88 and 0.6. okay, for the roof. For the fourth floor we are going to use the same value as previous here, 14.80. Okay, and we are going to calculate the FEM and then moment in upper wall and lower wall for level 4 and also roof. Okay, because we want to get what is the value here. Alright, let's figure out. Let's quickly check. Number 4 is check for top story. Okay, and we for top story here, we focusing on the vertical load only. Okay, we will kind of ignore the effect of wind and also the axial load. Okay, because that value is not that much affected or give effects on this top story. Okay, so let's write down here. Because we have transferred all the load to the bottom of shear wall. Sorry about that. Okay, now brace yourself, this will be quite lengthy. Okay, so let's focus on the roof. For roof level, okay, this is what we have. It is 3.5 meter, and we have this same slab of 6 meter. Okay, and we want to figure out the W. Okay, so this is level roof or roof level. Okay, for the stiffness of K wall upper, K wall lower, and also K slab. For this case is K wall lower. Okay, we have figure out the K slab from previous step. K of the slab is 0.744, and K for this wall here, wall lower. Okay, for the height of 3.5 meters, it is 3.720. Okay, now we want to figure out what is the W. Alright, so W equals to 1.35 GK plus 1.5 QK, and using the GK and QK for the roof. Okay, the one that I've shown you earlier, 1.35 times 5.88 plus 1.5 times 0.6 equals to 8.85 kilonewton per meter square. It is in unit kilonewton per meter square. And just like slab, we will consider 1 meter width. Since our width is too long, okay, we have a very wide width, so we consider per meter. So for per meter width, our W will be 8.84 times 1 meter. Then we will get 8.84 kilonewton per meter. Okay, so once you get the W, we next is we want to figure out what is the FEM, fixed end moment. Okay, so fixed end moment equals to the formula is WL squared over 12, and W is 8.84, and L is the 6 meter here. Okay, 6 meter here. We are considering the slab here, so the W 8.84, here is 8.84 times the L. 6 meter square over 12, we will get 26.52 kilonewton meter per meter. Okay, and next, normally we will distribute the moment, right? And for the moment distribution, moment in roof, we can say that equals to the FEM times the K for wall. For this case, we have just the wall lower, right? Times the K of wall lower, the ratio here, the ratio of the K, the stiffness, divided by the total K. For example, for previous step, we have the upper wall. Okay, so for the total K is the K of the upper wall plus the K of the lower wall plus the K of the slab. For this case, we just have K of the slab and also K of the lower wall. So this is equals to 26.5. Oh, okay. Times okay, since you cannot see, it is already at the end, at the edge of the slide here. I'll just move it here. Okay, so MR equals to 26.52 times the K for wall lower is 3.720 divided by the total K. You just have K of the wall 3.720 plus, for the K of the slab, remember to take only half of it. Okay, just half, 0.5 times 0.744. Okay, just take half. Then this will brings you equals to 24.11 kilonewton meter per meter. Okay, so this is the moment in roof level here. Okay, next we want to get what is the moment for level 4. Okay, because we want to get moment. Okay, this is roof level and this is level 4. In order to get this one, we just calculate it to be 24.11 just now, but now we want to find out what is the value at the level 4 here. So for level 4, so the same thing. Okay, for level 4 you have upper and you have the upper and the lower wall. Okay, this is just like previous step. Just the difference is the height of the wall. Okay, so this is 3.5 meter and 3.5 meter. In previous step, the lower wall is 4.5 meter, right? And you have the UDL. This is level 4. Okay, and we know what is the K of the slab, the same K, which is 0.744, and K for wall lower is the same, which is 3.720, and K for wall upper, since it is the same height, 3.5 meter, So the K is also similar, 3.720. Okay, and the W is all the W just now. Wait, the W here is the W for the roof. Okay, for the roof, the GK and QK is not similar as the floor. Okay, so for level 4 here, what are we going to do is to get the W, we can use the same as level 1 because they have the same GK and QK. Okay, this one here. Okay, they have the same GK and QK as in level ground to first floor. So we can use this 14.80 kilonewton per meter square for the W. Okay, we don't have to calculate the value of W. Okay, so let's use this 14.80, and also the FEM is also the same. Okay, because you have the same W, the same L, which is 6 meter, divide by 12, so we can use 44.4 kilonewton per meter. This one will be slightly different, okay, because the K of wall upper here or wall lower in this case is 2.894, but for our case we have the same K, right? 3.72, 3.72. Okay, this one is the same, just take half. All right, so let's do that. So the W just now is 14.80 kilonewton per meter, and the FEM is equals to 44.4 kilonewton meter per meter. Okay, next we want to calculate the moment in wall upper and wall lower, this one here. Okay, we are considering the level 4 here, level 4 right now. Okay, we want to get this one here. This one is wall upper, this one is wall lower, the value that we will get. Okay, so moment in wall upper will be equals to moment in wall lower. It will be equals because we have the same K. Okay, if we distribute the moment, you will get the same value. So it is FEM times K of wall, let's say wall upper, divided by the total K. Okay, since the K is similar, you will get the same value. So 44.4 times 3.720 divided by 3.720 plus 3.720 plus just half of the K of the slab, 744. This will brings you value of 21.14 kilonewton meter per meter. Okay, so this is what we get now. Once we have the moment at level 4, 21.14, so here is 21.14. At the roof, how much 24.11. Okay, 24.11 is here, 21.14 is here. All right, and we can see that 24.11 and 21.14, the higher value is 24 and 21, so 24 wins. And if you still remember, when we are designing the main reinforcement, before that we need to calculate the design moment, right? And in the design moment here, And in the design moment here, M02 is the higher value of M. Alright, so for the higher value of M is, for our case for level 4 here, is M at roof, which is 24. Okay, so in order for us to calculate the MED later on, the value of M02 will be 24.11. Okay, we will repeat also the same step here. We will need to calculate the design moment. Alright, so let's go for the design moment. Okay, we have 24.11. Betul kan? 24.11. Yep. Okay, and 21.14 and 21.14. Alright, so for the MED, it is equals to the maximum in between M02 and M minimum. We know that our M02 is 24.11 and M02 is equals to the M top, in this case roof, plus the M imperfection, right? So M imperfection now. We know what is the M top, which is 24.11. So M imperfection equals to NED times EI. The NED here in this case, we have to calculate. Okay, for previous step, for the wall at the ground to the first floor, we have considered all the axial load, all the effect of wind and so on. But for the from the fourth floor to the roof floor, we just need to consider this one only. Okay, this the axial load of this wall or this height only. Okay, so what are the things that we need to consider for the NED? So for the NED, we are going to take 1.35 GK times the H. Okay, bear with me. Let me write down the formula first. Plus the load from slab. Okay, so 1.35 GK times H. What is H? H is the height of the wall from level 4 to level roof. Okay, because we want to calculate what is the height, what is the GK of this column, this 3.5 meter column pula, wall. Okay, sorry, wall. Okay, and we only take GK only. Okay, and then this wall also carried load from slab, right? The 6 meter slab. Okay, so we also need to add half of the load from the slab. Another half will be taken by the other side of the support of that slab. Okay. So 1.35, what is the value of GK? Let's look at the value of GK. Here, okay, the self weight. That's why just 1.35 GK. Okay, we are considering the self weight of the wall only. Okay, we didn't add with the GK of the floor here or the roof 0.6, but for the NED, the axial load of the wall, we consider the self weight of the wall plus half of the load that comes from the slab. Okay, so your GK here in this case is 6.25. the self-weight of the slope. Okay, and when it is involving the self-weight, of course we need to times with the height of the wall. Okay, because this is self-weight, right? So 1.35, 6.25, h is the height of the wall. Okay, and load from slab, this one here, what is the value? Balik, sorry. What is the value of the W here? Okay, so the value of the W here is here for the roof, right? Because the 24.11 comes from the roof, right? So the W is 8.84. Okay, this 8.84, half of it will be will be carried. Half of this W will be carried by this wall, and half of this W will be carried by whatever the support here. Okay, maybe you have column here. Alright, so for this shear wall, it will take only half. So 8.84 divided by 2. This is already in kilonewton per meter. So we can add, just add the value here. Okay, 8.84 divided by 2. Right? So, but don't forget this is, let me write down here. GK is the wall self-weight. This is the wall height from level 4 to roof. Okay. So this will brings you a value of 56.05 kilonewton per meter. Alright. Next, we have figured out NED. Next, EI. Okay, the eccentricity. L0 divided by 400. Okay. So L0. You don't know the L0 that L0 or effective height is equals to beta times the L, which is the clear height, right? And we have figured out, as previous example, L is equals to 3,500 minus the thickness of the slab. Okay, so this is equals to 3325 millimeter. Okay, and the beta that we are going to use is 0.67. Okay, because you have the same thickness. There is no varies in the thickness. Okay, to get beta, I hope you still remember we are using the condition A, B, or C. Condition A is if the ratio of the slab and the wall is at least 50%. Condition B if it is 100% similar, or condition C if it is at least 75%. So for our case, it is 70%, so it falls under condition A. Alright, so L0 equals to 0.67 times 3325. This is 2227.75 mm. Okay, so this is your L0. Next, the EI. Oh, okay. EI equals to 2227.75 divided by 400. This give you how much? 5.57. Okay. So this 5.57 we can plug in to calculate the value of M imperfection, where M imperfection is equals to NED 56.05 times EI 5.57, but this is in unit millimeter, right? We need to convert to meter so that you will get 0.312 kilonewton meter per meter. Okay. So 24.11 plus 0.312, we will get our M02. Okay. So M02 is equals to M top plus M imperfection, right? Which is M top is 24.11. Your imperfection just now is 0.312. This gives you 24.42 kilonewton meter per meter. Okay. And you also need the M minimum here. Okay, so M minimum is equals to NED times E naught. Okay, where E naught is equals to 20 mm. We have figured out the E naught in previous step. Okay, your E naught will be 20 mm. So NED is 56.05 times 20 over 1000, change to unit meter also. You will get 1.12 kilonewton meter per meter. Therefore, your MED, which is equals to the maximum between 24.42 and also 1.12, of course, it is equals to 24.42 kilonewton meter per meter. Alright. Next, to design. Okay, to design, just like previous step, we are using the design chart where it is based on D2 over H. Okay, it have the same D2, it have the same H, so your D2 over H will be equal to 0.144, and we use design chart where the D2 over H equals to 0.15. Okay, and the things that we need in the chart is NED over BHFCK. Okay, NED is 56.05 times 10 power 3, change to unit Newton because your FCK is in unit Newton per millimeter square, divided by 1000 times 250, the thickness of the wall, times 30. This will give you 0.0075. And then you also need MED over BH square FCK. Your MED is 24.42 times 10 power 6. Okay, sebab because it is kilonewton meter. For NED just kilonewton. For MED is kilonewton meter, so times 10 power 6. Divided by 1000 times 250 square times 30. This will give you 0.013. Okay, so once we have that 0.013 and 0.075, we can look at design chart. Okay, 0.07 somewhere here, and 0.01 somewhere here. Okay, so it falls around 0.2. Not 0.2, this is 0.2, so 0.02. Okay, okay, from chart, ASFYK over BHFCK is equals to 0.02. Now let's figure out what is the AS. AS equals to 0.02. Okay, we will bring BHFCK to the right side. It will be times B times H times 30. And then the FYK will also bring to the right side. It is on divided. Okay, divided by FYK is 500. You will get around how much? 300. Okay, 300 mm square over m. Now you can see here, basically we have calculated the AS mean, right? AS mean is 250. Okay, it is not less than the 250. So we can also provide here the same vertical bar and also the same horizontal bar. Okay, since vertical bar is the same, we will use H12 350 also. So horizontal bar will also be similar because it depends on this 0.25 vertical bar, okay, or 0.01, but you will get the same thing. So it means that we can extend this reinforcement from bottom to the top of the shear wall. Okay, so basically for the last step here, we can use the same thing, provide vertical reinforcement H12 berapa tadi, 350. Okay, this is 3 to 3 millimeters square per meter in each face. Okay, and also we can provide horizontal reinforcement of H12 400. How much does 283? Okay, so basically we have checked the top story and we can extend the reinforcement. Alright, so that's it for this video. I'll see you at the next video part. This is part 5, right? So next video will be part 6 and that will be the final part, I promise you. Okay, see you in the next video.